let's solve this application problem from physics using the quadratic formula. We're given that an object is thrown straight up in the air, and the symbol v sub 0 is equal to the initial speed of the object, h sub 0 is the initial height of the object, and h of t is the height of the object at time t. So from the, physics, we know that the equation that describes the position height-wise of this object at time t, h of t, is equal to negative 16 times t squared plus initial velocity times t plus initial height. Now, we're also told that the initial velocity for this problem is 40 feet per second and that the initial height will be 6 feet. Then we're asked to find how long will this object be in the air. If they're asking us how long, they're asking us to find t. All right, now we're going to have to do a little common sense here. The object itself is going to return to its initial position when the height of the object is equal to what? Think about it. When the height is equal to 0. That's when it's going to be back on the ground, right? Okay, so what we're really searching for here is the t value in the equation in the cloud, the t value when the height, h of t, is equal to 0 when it returns back to the ground. Okay, so that'll tell us how long it was traveling in the air. All right, so we do that by replacing h of t in the cloud, the equation, with 0. Okay, so 0 is equal to negative 16t squared plus 40t plus 6. Well, this is a second-degree equation. All we have to do is determine what a, b, and c is and put it into the quadratic formula. A is negative 16, b is 40, and c is equal to 6. Plug those values into the equation. T equals negative b plus or minus b squared minus 4ac over 2a. Now look, you could make it easier on yourself by simplifying the equation first. Yes, there's a common factor that we can actually get rid of here. We can divide both sides by the common factor of the terms, which would be 2. And in that case, a would be equal to negative 8, b would be equal to 20, and c would be equal to 3. So it would be easier to work with in that case. Okay, so we use the same formula either way, the quadratic formula. So let me show you how it would look if we used the original a, b, and c. We would get negative 40 plus or minus the square root of 40 squared minus 4 times negative 16 times 6 over 2 times negative 16. Okay. Now, that would be equal to negative 40 when we simplified plus or minus the square root of 1984 over negative 32. And then we would break that up into two solutions, put it through the calculator, 2.64 seconds or negative 0.14 seconds. We're not going to use negative solution for time. Just throw that out. That's physically impossible. So here's our answer, 2.64. Now, if we had used the simplified values for a, b, and c and plugged them into the same quadratic formula, we would have negative 20 plus or minus square root of 20 squared minus 4 times negative 8 times 3 over 2 times negative 8. And we simplify that. Guess what? We get the same answer. Throw away the negative solution, keep only the positive solution because it's physically impossible to have negative time. So if it would be easier if you're not using a calculator, which you never use on my tests, okay, it would be easier to use the simplified version of A, B, and C.